Recording has begun, so we can go ahead and get started. I really liked this question of the day from last time, kind of what you missed the most, and I found it very interesting that people said socializing. Even if there's a lot of introverts in the class, socializing is something that people miss a lot. I think I miss haircuts, and giving in-person lectures are things that I miss, but socializing, it would be pretty high on my list also. I have made a new version of big data. So I mentioned last time that I'm encouraging you, to take the personality test. So you can click on the link here to take the test yourself. We're now up to 150 people in the class who've taken it. We're still holding steady at 75% introverts. So a lot of introverts. Maybe it's just all the introverts who've taken it so far. So it'd be great to have a lot of other students take the personality test. I will keep creating new versions of it as we go forward, so it's not too late to have your data included. And it makes for a nice big data file that's helpful for us to be able to see if you've got the correct output and so forth. And you can see your own personality type that way. Make sure that your program is getting it right, while you have your data too. Anyway, so I encourage you to run the personality test if you haven't. I did a little computation. I noticed we had done 22 lectures, one of which was an optional lecture. So it's like 21 real lectures, 1,050 minutes worth of recording. And I went into Panopto to get information about how many minutes people have watched. And I connected that with data about how people are doing on homeworks. And I put together a little thing that you might find interesting. So for the students who've watched at least like 750 or more minutes, there are 286 of you, which is around 2/3 of the class. That's great. That's good that there are so many students who are watching at least like 3/4 of the lectures. And the homework score is pretty high, 73.5. That's out of 86. People who've been watching in the middle, half to 3/4, there's 49 of them. Slightly lower score, still not bad. It starts to really drop off when you get to people who've watched less than half of the lectures. The average score is down to 66.8, and people who've watched less than 1/4 of the lectures down to 61.4. Now, the famous phrase that correlation does not imply causation. It could just be that people who work hard also watch lectures, and so maybe you were going to get high scores even without. Maybe the lectures are worthless, but you're a hardworking person, so that's why you get a high score as well. But it's at least suggestive, I think, that it matters. And maybe, in a way, I'd like to scold the people who are, in this group, these 49, but they're probably not going to watch this lecture, so I can't. But in a way, what I'd rather be doing is encouraging the 286 of you who've been watching to say that I think it's really important. I've said it before. I know it's difficult this quarter to motivate yourself to do all of this stuff. This is not an ideal format. I prefer teaching in person. I know the videos are a lot more dull than doing it in person, but I think it really matters in terms of your performance in the course. This is a much more important factor, I think, than whether you have prior programming experience. So those of you who are kind of putting in the effort, doing what we're suggesting that you do, going to section, working on homeworks early, those things work. So anyway, that's a little bit of evidence that that is so. Okay, well, today we're moving into new materials. So I released Homework 7 on Monday. So again, as usual, that means that the material you needed for that assignment, we finished on Monday. And we'll go over some of it in section tomorrow. So that's kind of the Chapter 7 stuff. Now we're moving into Chapter 8. So that's going to be today's lecture and Friday and Wednesday of next week. So I mentioned this before, that what we've been studying is something that we would call procedural style programming, and we've been doing it with static methods. And you could kind of think of it as action-oriented. We've written methods with names like draw top, draw bottom, draw X, the command-like ways of doing things. This is an old style of programming. It's not kind of the style that Java was designed to do. Java was designed to be an object-oriented programming language. Object-oriented programming, OOP, or OOP, is what Java was designed to do. what my co-author and I found when we were first teaching Java, is that we found that it didn't work very well to try to teach objects early in the course. Now this could be an indication that objects are just hard, that objects are hard for people to learn. That might be true. Or it could just be that the syntax in Java is complicated enough that in Java objects are hard to learn. In any event, our conclusion was that it was better to emphasize procedural programming first. So that's what we did in the first 7 chapters of the book. The idea is to give you a foundation, to get you to master certain skills so that then you could move on and learn about object-oriented programming, and that's what we're doing starting today. So we're moving into chapter 8, and we're trying to understand kind of the model that Java was designed for, which is working with objects. So that's what we're going to do start today. I wanted to take a little bit of time. Partly it's because I've got some gray hair, so it's one of the advantages of having a little gray hair. It's been around a while longer. I can tell you stories about things. I remember things that other people weren't around for. I think it's nice to talk about some of the history of object-oriented programming, where it came from and so forth. So, and boy, this is a whole lot less fun than if there was a group of people here, because I'm always really interested in what answers I get, to see what kind of mastery people have of history. But one of the questions that I begin with is, there's a company I want to talk about, a corporation, great big mega company from the 1970s that was very rich. And because, they had been wildly successful, so successful that the name of the company had become a verb in English. And everyone kind of had the sense, this company's going to dominate, forever. There'll always be a huge, powerful corporation. And they had enough money that they could do lots of research. So anyway, I usually ask that question, and I get people to make suggestions. And often people suggest IBM. IBM was a big, powerful corporation, and they did have some research at the time. Some people will mention AT&T. That's actually interesting when people do know about that. That's true that, the AT&T was a huge conglomerate that got broken up at one point. But it was a big corporation, and it did pay for lots of research at something called Bell Labs that produced lots of really great stuff in the 1970s, including Unix and C. So those came out of Bell Labs. So that's true. But, the corporation, I don't know whether some of you have figured this out or been able to guess, but the corporation is Xerox. The copy machines, and we started saying things like, I'm going to go Xerox something. It became a verb. I'm Xeroxing my stuff, because it became synonymous with copying. And they had a lot of money, Xerox. And so in the 70s, Xerox set up a research group known as the Palo Alto Research Center, Xerox Park. And they gave them a lot of money. And there were a lot of things they were doing there, but I think what they had in mind, that their mission was to invent the computer of the future. So that's what they were trying to do in the 1970s. Very interesting group, and kind of what they did. I know a lot of people will talk about the idea of visionaries, in the computing field and so forth. I often feel like people say someone's a visionary when they're not necessarily. Bill Gates, I think, is a very smart man, a great businessman. He didn't seem to me to be such a visionary. For me, one of the things I would vote for is Alan Kay. He worked at Xerox Park. He was one of the primary people in that group. And Alan Kay really was a visionary. If you're interested in checking out somebody, Alan Kay would be really worth checking out. Alan had his own vision for the computer of the future. He had in mind something that was about the size of a piece of paper that you would hold in your hand and that you would use to read things, read books, and to do email and communications with other people. All your documents, would be kept on this thing. It sounds an awful lot like a tablet. He called it the dynabook. So he was talking about that all the way back in the 1970s, something that would work like that. They didn't make the dynabook. That was a little too ambitious. But Xerox did make something known as the Xerox Alto, which was sort of their version of the computer of the future. When I went to Stanford as a graduate student in 1979, I found that there were a lot of Xerox Altos that were in the building, the computer science building. So they'd been donated by Xerox so that we could play with them and learn how they work. They turned out they were too expensive. You know, in today's dollars, they would cost something like $100,000 each. So they were pretty expensive. But they were pretty great computers. I really enjoyed using them. I learned a lot in doing that, and starting in 1979. Well, so at this point, what I normally do is I ask people what changed as we went into the 1980s. And there's many things people point to. There was the PC revolution. That's very true. That was becoming a big deal. You know, IBM PCs at the time. There was a startup called Apple that started doing Apple IIe. You know, there was all sorts of devices that people were using. So there were changes going on. But there's kind of one change that I think was the biggest single change going on in the 1980s that changed everything from that point on. Not immediately, but kind of everything moved in that direction from that point on. So that's my candidate for the huge change, and I ask people, and they give me various guesses. I have something for us to watch that will kind of give you my...
Today we celebrate the first glorious anniversary of the Information Purification Directives. You created, for the first time in all history, a garden of pure ideology, where each worker may bloom, secure from the pests, obeying contradictory thoughts. Unification of the rules is more powerful a weapon than any fleet or army on earth. We are one people, with one will, one resolve, one cause. Our enemies shall talk themselves to death, and we will bury them with their own confusion. We shall prevail.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
So that's a very famous commercial that aired during the Super Bowl in 1984. That was the only time it aired in a major market. Apple had aired it in a tiny market the year before so that they could get into certain competitions for best ad. But basically the one big showing was it was a Super Bowl ad, right? You know, everyone talks about the expensive Super Bowl ads. And I feel like it really was, it was saying that the Mac was going to be a very different kind of thing. And I believe that the Mac was. It's funny, that commercial, it was directed by Ridley Scott, who was a famous Hollywood director who had done Alien and Blade Runner, known for his visuals. It didn't even show the computer. I mean, it just kind of claims, you know, it's kind of playing on George Orwell's 1984 and saying that this is our future, we're going to be freed from all of this. I kind of think of all those sad people in the audience as being procedural programming people or something, you know, using the old versions of the operating systems and so forth. So in terms of kind of what was the big deal, I would say that it was the introduction of graphical user interface, what we call GUIs, graphical user interface. And the Mac was the first major commercial one. The Xerox Alto had a GUI. So I had been using something very much like a Mac for 5 years, you know, before it came out. It was very familiar to me when it came out because I'd been, you know, working this way with the Xerox Alto. You know, anyway, I don't want to go too long with history, but you know, there's a story that the Lisa team at Apple had a day-long presentation at Xerox where they were shown the Alto and all of these kinds of ideas by people like Alan Kay, who later went and became like chief scientist at Apple or something. And the story they tell is that at the end of the day, Steve Jobs said, we're dropping everything that we're doing and we're going to do this instead. You know, and Apple gave Xerox some stock options and created the Mac, you know, a graphical user interface. So, this is my claim, is that I think that it really changed everything because later it led Microsoft to do Windows, you know, and then everything kind of moved in that direction. Well, let me talk a little bit about what we had before that. So before we had the graphical user interface, we were using what are known as command line interfaces. I showed this a little bit at the end of the last lecture, where I went into a terminal window on my Mac where I was typing commands at a command line. And that was kind of the way that things were done before we had graphical user interfaces. In a graphical user interface, you have icons that represent things. You move them around. You have a virtual desktop. You have a metaphor of a desktop. Command line interface was very different. So if you wanted to think about it, I'll often ask people, does anyone know if you went into a Windows command line interface, do you know how to delete a file? And sometimes people know, sometimes they don't. But there's a command del, short for delete, where you would say something like del data.txt. And that kind of shows you the way things were done in those old command line interfaces, is that you begin with something that's action-oriented, delete or del. You know, it's a verb. So you begin with a verb, and then you give a noun. I want to do this action to this thing. It was verb followed by noun. That's procedural style, action-oriented, command-oriented. That's the old style way of doing things. How do you delete a file on Mac or Windows? You know, what would you do instead? There's lots of ways to do it, but you know, all of them basically begin by clicking on the icon for the file. You know, maybe you right-click and there's a little sub-menu that shows up, or maybe you click and you drag. You know, there's lots of different things you could do. But the point is, you begin by pointing at the object that you want to be doing something with. So you begin with the noun, and then you say the verb that you want to do to that noun. So this file moved to trash. You know, so I kind of begin with the object, the noun, and then I say what verb, what action I want to perform on that. And the people at Xerox Park believed, and I think that history has kind of proven them to be right, that this style of interacting with the computer is a lot more intuitive, because people are used to manipulating objects, you know, and the idea of a desktop with objects on it, and I manipulate things and move them around and so forth, that was very intuitive. In fact, I would say that the desktop metaphor has been so successful that we sometimes forget that it's a metaphor. We think we actually are moving things when we drag an icon around. I mean, that's just a little cartoon that's being shown on the screen for us to reinforce the metaphor. So I think some people don't even realize that it is a metaphor. They think they're actually, you know, dealing with something like a desktop. So I think they were right. The Xerox Park people were right about on the operating system side, that this was wildly successful. You know, the other point of showing you that Mac commercial was just to kind of give you a little bit of the attitude that Apple had at the time. We're going to save the world. We've got the fantastic computer. In the years that came after, you know, they tended to do commercials that were things like, there was one where you see a Macintosh in a box being wheeled through one of these offices that has cubicles, and everyone's looking around their cubicle. Who's getting a Mac? Who's getting a Mac? Is Fred getting a Mac? You know, it's like everyone is jealous. They want a Mac. How come Fred gets a Mac and I don't get a Mac? Well, that was very much the Apple attitude at the time, is that we are the cool, you know, great computer that's going to make life better. You know, you can decide whether you think they were right or not, but certainly before Windows came out, there was a lot of reason to believe that Macs were easier to work with. Now, they also thought, the people at Xerox Park, that from the point of view of programming, that it's easier to reason about objects than to reason in a procedural manner. And I think there they've been less successful. It's not so clear they're right there. This idea that my co-author and I have, that we teach procedural style first and we teach objects later in the course, this has become the dominant teaching strategy for people teaching Java in intro courses. You know, we've won basically over time. You know, it wasn't clear when we wrote the book, started writing the book back in 2004, that we were going to win, but it's clear from the textbook sales that the people who are teaching Java are doing procedural first and object later. So it's been a little harder, you know, I mean, on the programming side, objects have been a little less successful. But, we can't let you leave this course without having experienced objects, and so we're going to talk about them in Chapter 8, and there'll be an assignment. All right, well, I have a bit of code here where I have notes about what it is I'm going to want to do. I'm going to want to construct a point P1 with coordinates 3, 5, and a point P2. So imagine like coordinates on a screen, a point 1 on the screen and a point 2. You're dealing with that for baby names, right? Points on a screen. So you could imagine something like this. And kind of the way you've been doing it, we have been doing it, is you could imagine having variables like x1 that you'd set to 3, and y1 that you set to 5, and x2 that you set to be 12, and y2 which you set to be 4. And by the naming convention, you're kind of implying that these two go together, that's a 3, 5 point, and that these two go together, the 12 and the 4 go together. So that's the way we've been doing things. But now we're going to kind of see a better way of doing it. So let me create a new Java file, and I'm going to introduce a public class that I'm going to call point. There is a point class in java.awt, and my co-author and I decided to use the point class as our primary example. So Chapter 8 uses point class over and over again to kind of try to teach you these different concepts. And it is nice that there is kind of a built-in thing that's like this. So we're a lot of times, the ideas that we get for how it should be constructed is by looking at what they did in the version that they wrote for Java. In doing this, I mentioned that one of the things that we see students struggle with is there's a lot of syntax, a lot of different details to deal with in dealing with defining your own classes. And so to try to make that easier, what the chapter does and what I'm going to do in this lecture and Friday's lecture is that we kind of build it up in stages. If I showed you kind of the final version of the point class, I think you'd get, your head would explode. It'd be a little bit too much. So I want to build it up in stages, and I think it's helpful for you in understanding it to kind of pause at each of these different stages and make sure you understand that version of it. So we'll see 4 different versions of the point class. We're going to kind of pause and understand these different versions of it. So in terms of the very first version of it, the thing that's most important to understand about a class is that it allows you to do the kind of thing that we're doing here, that it allows you to group together related data. So if I have an int x and an int y that are related to each other, then I can put them inside of a class. And so this is like the simplest possible form that a class could take, is to include the x and the y inside of the point. So this is going to be version 1. Very, very simple understanding. And it's reinforcing the idea that the most important thing for you to understand about a class is that it's a way of grouping data, a way of putting together related data, an x and a y. Now, there's some terminology we're going to be using. So we'll be talking, about the idea of a class. And let me say there's only one class. So there's this point class that we're defining. We create a separate file for it. So you notice that separate from my file over here that has main, I'm making a separate file over here for the point class. So this is going to be something new, is we're going to be creating multiple files, one for each different class. So there's only one class, and the primary analogy we use in the book is that it's like a blueprint. It's a description of structure, it's a description of how to build something. And so it's important to understand that the class is not the actual thing. So if you had blueprints for a house and you thought this was a gorgeous set of blueprints, I want to live in this house, and you have just the blueprints, you can't move your furniture into the blueprint. You can't live in a blueprint. A blueprint is just a description of how to construct something. So that's an important thing to understand, is the class is like the blueprint, and it's not the actual thing. But then what we can do is we can construct many objects So you can take that blueprint and build a house with it, and take the blueprint again and build a second house, and take the blueprint again and build a third house. So there could be 3 objects that are all of that class. They've all been built using that blueprint. So you can construct many objects. Another word that we'll use interchangeably with objects is instances. So that's a word that's used a lot as well, as an instance of a class. So we can construct many objects, many instances of a class. So using the blueprint, we can construct. And those are objects or instances of this class. They were created using that blueprint. So that's kind of some basic ideas. There's a little phrase that I'm going to mention that has some of the main concepts of object-oriented programming in one little pithy statement. I'm going to say an object encapsulates state and exposes behavior. This is something that's going to take a while to explain all the different pieces here, but we do use this terminology, so I wanted to introduce it early. And what we're going to talk about is this state idea first. So let me tell you, the int x and int y technically are known as fields. So that's the term we use for having this x and this y that are inside of a class. And these fields are like variables, so they kind of have a status that are like variables, and they store the state. That's the state information. So the state of an object would be what's x and what's y. That's the state information. It's unfortunate that, we've been writing things like public static void, do something, and inside the curly braces we've said int x, int y, other lines of code. We've been writing methods like this that have like an x and a y. And it's really unfortunate that this syntax is exactly the same as this syntax, because it's going to make you think it's the same thing, and they aren't. It's something very different. And so even though the syntax is very similar, it's important to kind of understand that it's very different. We're going to take a lot of time trying to explain this, kind of how it is that fields are different. But let me mention a few ideas. So these are local variables, local to a method. They're brought into existence when the method is called, and they go away when the method goes away. So they have a very temporary lifetime. These things have a much longer lifetime. They exist inside of an object, and as long as that object is still around, the x and the y will still be around. The analogy that the Xerox Park people gave for thinking about the object-oriented programming, just like with the desktop metaphor, imagine a desktop that has lots of objects on it. And so if there's a point object sitting on your desk, it's got an x and a y inside of it, and that x and that y doesn't go away. It's there inside the object. In fact, if you pried open the object and peeked inside, you'd find an x and a y. So that's a very different notion than the idea of a temporary local variable that goes away. So it's a little unfortunate that fields have that different kind of syntax to them. The same syntax as local variables, even though it's a very different concept. So let me do a save command. I do want to save it as point.java. And let me make sure that it compiles. Very simple version that just has the x and the y. So what I'm going to do is, here I'm going to say that I want a point P1, which is a new point. So I'm going to construct a P1, and I'm going to make P2 be a new point. So now I'm creating actual objects, actual instances of the class by calling new. Another analogy that's sometimes used for this is that you could think of the point class as being like a factory. That's a bit of terminology object-oriented people often use, is the idea of a class as a factory. So I kind of, what I'm doing over here is I'm calling up the point factory, and I'm saying, make me a fresh, brand new point, and I'll store it, the reference to it in my variable P1. And then I ask again, I'm ordering a second point from the point factory, and give me the point, and I'll store the reference in P2. Well, let me show you. This isn't going to be right, the right thing to do. Let me show it to you, though. We'll kind of debug just to make sure we understand the differences here or what's going on. So I set a little stop here so that we construct that P1. So here's our point P1, and there's a a little icon right here that indicates that we can open this thing up. So that's like what I said, prying open the object. So let's take a look. When you open it up, you can see inside the object there's an X and a Y. So then when I execute these other lines of code, I'm setting X1 to 3 and Y1 to 5. This was the old style way of doing things where all the variables were in something like main or whatever. They were in this outside structure. Here, the values of the X and the Y are inside of the object. And I'm going to let it execute the next line of code where it makes point P2, and then I can open it up and see that it has an X and a Y inside as well. And this X and this Y are independent of this X and this Y. So, I mean, that's the idea of the blueprint. The blueprint said, whenever you make a point, make sure to include an X and a Y. When we talked about calling new on arrays, I mentioned that arrays do auto-initialization. They set all the array elements to the 0 equivalent of the type. And the same is true of objects. All of the fields are set to the 0 equivalent of the type. So that's why we have a 0, 0 here and a 0, 0 over here. But clearly, this isn't what I want to do. I mean, I don't want to be dealing with an X1 and a Y1, and then this would be about to create, you know, an X2 and a Y2, which I don't want all those variables floating around. I want to just deal with a P1 and a P2. So obviously what I want to be doing is, I don't want to be setting a variable X1 to be 3. I want to set this X to be 3. So how do I do that? Well, it's inside of the point object that P1 refers to, and we can use the dot notation. We can say P1.x. So that's a way of saying, I want the X that's inside of P1. And similarly here, I can say P1.y. I want to set its P1's Y field to be a 5. Here, I can do P2.x. So it's the second point's X that I'm interested in, and P2.y. So I can set the second point's Y coordinate. Let's end this one and recompile and then do the debug again. So we can see it's setting up the X and the Y, and you can see it's set to the 0, 0. And then I'm going to use these lines of code to reset, you know, to kind of reset the X to be a 3 and then reset the Y to be a 5. Sometimes at this point people ask me, couldn't we put them up here in the parens? The answer is going to be yes, but that's one of the later versions. So for right now, this is the way we're going to do it. So it resets, watch the little X here, you'll see it get reset to be a 3, and you see the Y here being reset to be a 5. Again, I used P1 dot as a way of indicating which X and Y I wanted to work with. Then I make a P2 object, and if I open it up, it got initialized to a 0 and a 0, but then I set it to be a 12 and a 4. So I've kind of initialized those two different point objects. Okay, so that's a first introduction. Normally I see questions, and there's often lots of little questions, but this is this first version that just has the XY values in the point. What I want to do next is I want us to think about some operations that we might perform on this point. So I'll get rid of this. So what it says to do after the construction is to translate P1's coordinates by -1, -2. Translating is moving it around, like, you know, changing the coordinates on the screen. So like translating -1 is, you know, -1 in the X direction and -2 in the Y direction, which I guess goes up, right? So, you know, or translating by 6 and 8. So there is actually a translate method in the built-in point class. So I'm kind of copying something that's in the built-in point class. What I want to do first is I want to kind of construct this the old-fashioned way. So I want to do it the procedural programming style way. So I have in mind that there would be some kind of a translate method that I'm going to call, you know, with some parameters, and translate, which I'll call a second time with some parameters. So I'm going to kind of give two calls, one to translate the P1 by this, and one to translate the P2 by that amount. So we want to have a public static void method called translate, We need to figure out what its parameters are. And what is it that we want to do? Well, if I were dealing with the point P1, I kind of want to do P1.x is assigned to P1.x plus something. You know, that's what translating means, is to change the x-coordinate by a certain amount. Here I'd be changing the x-coordinate by a -1. You know, I'd be adding a -1 to the x-coordinate. So that's the kind of thing that I want to do, is that I want to be resetting an x-coordinate by some amount here, the y-coordinate by some amount here. So we're going to need to know those values, the -1, the -2, the 6, and the 8. And I like to kind of think of those things as being a delta x and a delta y. So I'm going to call them dx and dy. How much are you shifting the x-coordinate by? How much are you shifting the y-coordinate by? And that means that in here, we're going to need to include the -1 and the -2 as the delta x and the delta y. We're going to need to include the 6 and the 8. But we need more than just that. You know, this thing, you know, it's supposed to be changing dx, but is it supposed to be changing P1's x-coordinate or P2's x-coordinate? And it can't access P1 and P2 anyway because of scope issues. You know that. You know, so we're going to have to pass in something that tells it what point to work with. So we're going to need an extra parameter. I'm going to call it P, that tells it what point we want to work with. So in the first call, I'm going to pass in P1. And in the second call, I'm going to pass in P2. So I'm going to translate the coordinates by first working with point 1, by translating with a delta x, delta y of -1, -2. Then I'm going to work with P2 with a delta x, a delta y of 6 and 8. And so what I can do inside of here is I use the kind of the generic name P. I can say P's x-coordinate is changed by delta x, and P's y-coordinate is changed by delta y. So I add dx to x, I add dy to y for this point that I'm calling P, and that should do the translating operation. We didn't want that. That was just kind of a, you know, we were talking about that line of code. Let's set a stop here and do a debug to kind of understand what's going on here. So we're making a call on translate, passing it P1 and a -1 and a -2. So notice P1 is object number 186 according to JGrasp with a 3 and a 5 in it. And I'm passing P1 to this thing known as P. So I've been talking about it for a few lectures now, the idea of reference semantics. These are objects, and so this is going to behave the way we've been talking about how arrays behave. So P is going to be a copy of P1, but P1 stores a reference. So P also has a reference. So basically, it's going to be 2 references to one point object, to this point number, or this object number 186 with a 3 and a 5 in it. So in main, P1 has a reference to that object 186. Let me show you what happens when we go into the method. Notice that P has been set up so that it's also referring to object 186. It is a second reference to that object that has the 3 and the 5 inside of it. And that's why when I set P's x-coordinate, when I add in dx, you're going to see this 3 go down by 1 because it's adding in the -1. And the y-coordinate is going to go down by 2 because it's adding in the -2, which is the dy. So that goes down by 2. So the y-coordinate went down by 2. So now what P is referring to has got the 2 and the 3 in it. But that was object 186. Remember, 2 references to the same object. So when I come back to main and I come back here, you'll notice that P1 has got the 2 and the 3 because it's that same object. It's object 186. So it's important to understand how this works, to understand the reference semantics, to understand that we can do it in this way, and that by passing the reference that allows you to change what's inside of the object. This is going to be one of the things that's very powerful about objects, by the way, is that, we haven't been able to change things like this. We've only been able to return something from one thing from a method. But now if you pass in an object that has 18 things in it, we can change 18 things. So just like with arrays, with things like these point objects, we have the ability to change what's inside. And I'll show this to you just, briefly. P2 is pointing at object 187, which has got the 12 and the 4. And when I go into the translate method, now P is referring to object 187 that's got the 12 and the 4. And it does the updates to that one. And we come back to main and find that P2 has been updated in that way. Okay, so that's kind of what I wanted to show in terms of a static method version of this. But that's the procedural approach. That's the old style approach. That's not the way that we want to do it. And notice, by the way, that is kind of in this old style of verb followed by noun. So what I'm doing here is I'm verb followed by noun. I'm saying I want to do the translate command, and the noun, the thing I want to do it on, is P1. I want to do the translate command using P2, verb followed by noun. That's the old style way of doing things. That's like the command line interface. That's the old style. So in the new style, we're going to want to think about the following. So, we can have a translate method like this in our class. There's a term I'm going to be using, and I'll use it more next time, but you'll see it in the name of the class that I put on the calendar for today. We refer to this program here that's using these point objects as being a client class. It's client code, a client of the point class. It's a user of the point class. And so this client code, this is kind of a program I've written that manipulates points. I could imagine writing 45 programs that manipulate points. And what if a whole bunch of them, what if 30 of them want to translate coordinates? Well, why should all 30 of those programs have to have a translate method in them? Why should the client code have to write this method over and over and over again? Isn't there a more convenient way of doing that? And the answer is yes. And so this is kind of the next important thing to understand about classes, is that you have the ability to include methods in a class. And so that's what we're about to do here, is to include what we're going to call instance methods in a class. And this is basically behavior. Instance methods we refer to as the behavior. So, and there's a joke that a friend of mine, Owen Astrachan, who teaches at Duke, I first heard this joke from him, although I think it's been floating around in the object-oriented community for a while. But it's a play on a famous quote from John F. Kennedy. The quote is, "Ask not what you can do for an object, ask what an object can do for itself." So why should I, the client, have to do the translating task when the object itself could have the translating task? So let's have this be inside the object. Now, I used a different word here. I called this an instance method. Not a static method, but an instance method. So it's a method of an object, a method inside of an object. I kind of wish that Java had introduced a keyword like instance, so that you would put the word instance in the header instead of the word static, so that you would understand that you have static methods and instance methods. That's not what Java chose to do. You'll notice it's not in purple. They decided that instance methods are so important that they're just the default. So the way that you make something an instance method is by not including the word static. So for what you're going to be doing with these object assignments is you're just going to stop using that word static. So we're creating an instance method rather than a static method. So there's another analogy that I'll use sometimes. So if I'm trying to think about what's going on with an object, I sometimes use an analogy of cars. And the first car I ever bought was a Honda Accord. Loved it a lot. So I could imagine that I'm not inside a car. I'm kind of at a lot where there's a bunch of cars, and maybe there's 5 different Honda Accords that are in front of me. It's like having a desktop that has objects on it, So there's this car 1, car 2, car 3, car 4. And if I was thinking about the steering wheel for a car, each one of these cars has a steering wheel in it. So if I was outside the car, which is like what's true in this client code, I'd have to be specific. I'd have to say it's P1's X that I'm interested in, or P2's X. I'm interested in the steering wheel of car 1, or I'm interested in the steering wheel of car 3. Which car's steering wheel am I interested in? But if you're in the car, that's a different view. This is kind of the inside view of an object. If you're inside a car and somebody said, turn the steering wheel, you'd know what they mean. There's only the one steering wheel inside of a car. And so inside of a class, we can see that there's a thing called X and a thing called Y. So we don't have to say P.X and P.Y. We can just say X and Y. So this is something that's really nice about fields, which is that we can just refer to them directly in our instance methods. Some clever students at this point say, isn't this the global variables that people asked about earlier in the quarter? And the answer is yes, this is acting like global variables, that we get to declare an X and a Y here, and throughout the whole class, we can refer to them as a simple X and a simple Y, and we won't need to pass the point as a parameter. That's kind of the main idea here, is that we just know what X we're dealing with and what Y we're dealing with. So that's how you create an instance method, and it's different from the static method in that it doesn't have the keyword static, and we don't have to pass the point. And then when we go to call it, so let me comment out this kind of the old version of it. That was the verb-noun version of it. The way that we call an instance method is by saying which object it is we want to work with, in this case P1, and I'm going to say, hey P1, I want you to translate your coordinates by -1, -2. Hey P2, now I'm going to talk to you, and I want you to translate your coordinates by 6 and 8. So you can see that here I'm giving the noun followed by the verb. It's that same reversal that we had from between a command line interface and a graphical user interface, is that we program it in this different way. We begin with the noun, the object. P1, you're the object I want to talk to. I want you to translate your coordinates. And then a moment later, P2, I'm talking to you, and you're over here on my desktop. So P1 might be over here, P2 might be over here. Now P2, I'm talking to you, and I want you to translate your coordinates. So that's kind of some of the major ideas of what's going on here. Let me set a stop here. And I did want to mention one more idea about this, which is that, how does it know what X and what Y to work with? There's kind of this question of how does it, if I don't pass it as a parameter, how does it know? And there's a concept known as the implicit parameter that's important to understand. Well, it's like when you click on an icon, and then you give the command move to trash, it understands that that's the thing. That's the object you want to move to the trash. There's an implicit parameter because you selected it. You clicked on it. And here I'm talking to P1. I'm saying to P1, I want you to do this task. So it's the implicit parameter on this call, and P2 is the implicit parameter on this call. And you can see, I don't know if there was something I needed to do to compile, but we might, I guess I added a little comment. So we'll debug. And so you can see P1, object 186, that's got the 3 and the 5. And if I step into the method, I'm over here in the class where there's the translate method using the X and the Y. And notice I can see what delta X and delta Y are, but where's X and Y? How does it know what the X and the Y are? Well, some of you might have noticed there's something here called this, which is referring to object 186. And if I open it up, there's the 3 and the 5. That's the implicit parameter. So there's a special keyword in Java, this, THIS. and it's understood to be the object that you're talking to. So I'm talking to this object, and I want it to change its x and y by the delta x and the delta y. I come back over to here, and now it's P2 that I'm talking to. So when I go in the method, it's object 187. That's the implicit parameter that this is set to. I'll mention just a couple more ideas because we're running out of time. In the textbook, there's a picture of this, which I think is a good way of understanding it, is that if you're thinking about the blueprint idea, a class as a blueprint, one of the ways of thinking of it is that when you ask the point class, the point factory, to make you a point, it puts three things into it currently. It puts in an x, it puts in a y, and it puts in a translate method that manipulates that x and y. Just like putting a steering wheel into a car that turns the wheel of that car. That's kind of a way of thinking of it. I'm going to post something to the calendar for today that has an extra method in it. We didn't have time to get there, but it's fine. This is a little distance from origin. It's another example of an instance method that you can construct. And then I'm going to include kind of a version of this that prints out the distance of P1 and P2 from the origin. So that kind of concludes our second version of the point class, and we'll do versions 3 or 4 in Friday's lecture.